Okay, so we're going to get started. Thanks so much for coming to our talk on augmented reality with Meta. Who here has done some augmented reality development before? Let's see a show of hands. Okay, about third, half, 40%. All right. Who's come by the Meta booth? Who's tried out the Meta 1 dev kit? Okay, good show of hands. Excellent. So I'm Soren. I'm the head of product for Meta. This is Joseph. So all of you who are Meta 1 customers will know Joseph as the surprisingly Australian voice of Meta, the suave voice of Meta. That's him on all the intro videos on our dev center. We've got a few more Meta people. We've got Walter, our head of marketing there, and Brittany, who heads all of our events. Thanks for coming to hear us talk. We're going to talk about basically augmented reality. Joseph is going to do the heavy work of daring to do a live demo that involves coding, and I'm just going to kind of give you some high-level stuff. So why do we think augmented reality is important? Well, fundamentally, augmented reality can kind of transcend what you can do computing with screens and make computing more human. And that's really the crux of this talk. And so I'll start out just giving you a little bit of an overview of Meta, because if you just kind of look at who we are, it kind of gives you some insight into what augmented reality is. First of all, our CEO, Miron Grivett, CEO and founder, he's a neuroscientist. And so we kind of have neuroscience baked into our DNA. And you'll see with Joseph, it's relatively easy to build an augmented reality app, but it's hard to get it to really fit in well with the human, with our perceptual system. And so we got several neuroscientists on staff for that. We also have Alan Beltran, who came to us from the Google Tango project, building sensor arrays to help track the world. Also a big part of what we do. Jace Hansen, who did the Iron Man HUD. So we're bringing Hollywood ideas into augmented reality. And two of the real founders of wearable computing and of augmented reality, Professor Steve Mann and Steve Feiner. Steve Mann has spent more time with wearable computing than just about anyone. And you'll see as we go through this that the wearability, the hands-free aspect, all of that is really, really important. We started as a Kickstarter company, and we started building out the whole stack, which was crazy and audacious, but we did it. We shipped a product. And we've now kind of graduated and grown up a bit from the Kickstarter days and raised a $23 million Series A and built out the team. And we've built out that full stack as well. And to build that out, we're incredibly indebted to Unity, because without Unity providing this platform that does so much, we wouldn't be anywhere near where we are. And we think that this really means that for all of you who are getting into AR and VR, there's an incredible opportunity on the Unity platform. I think something like 95% of the VR content is built on Unity, and it's similarly high for AR. So this is the Meta 1. This is a product we've been shipping for about a year. It's a dev kit. I think probably many of you have them. We've shipped well over 1,000 of them, kind of a small number so we could curate the community. And what's unique about it is, first, it has a see-through display. So unlike virtual reality, augmented reality, you see through and you see the world, and then you see digital content out in the world. But there's something very important to what we did that like others with Google Glass and folks didn't do, and that's to have sensors, to be simultaneously tracking what's going on in the world and seeing stuff projected into it. And that's the fundamental problem that you need to solve with augmented reality, and it's called the registration problem. It's being able to anchor digital content to some place in the environment based on a map of that environment. So we're doing full environmental tracking. We're registering content to the environment and to the hands, and that makes us pretty special. So come by our booth and check it out. But what's really interesting with all this is kind of like, well, what can I do with it? There's one thing to show novelty, to show things that are kind of cool demos, but augmented reality has some very deep and impactful types of applications. And we believe also very deeply that augmented reality can enhance our humanity. And if you take this somewhat logarithmic time scale, back from the days of stone tools when we were beating on rocks, everything was in the world and everything was aligned, kind of what we're hearing with what we're seeing, with what we're touching. Our different sensory systems were all engaging in that task. So why can't we do that with digital content? Well, as we've kind of gone through the development and we've developed around screens, and we see that screens, as intimate and personal as our iPhones and tablets and things are, they can also separate us from the world. But with augmented reality, by putting content into the world through a see-through display, being able to make eye contact with people while looking and interacting with digital stuff together, we can bring people closer, and we can create that same intimate experience, but we can do it in a way that is bringing people together rather than isolating people. So for example, if you're a 3D designer, you can put a car into the world, and you can place it on a desk, and you can see things at true scale. Well, probably not a car on the desk, but you can see it the size that it's actually going to be. If you're looking at a screen and you're a designer, you can't really tell that. It takes years of practice. But by being able to put it here, I can see a digital model in the true size and in the relationship it is to things in the environment. Similarly, if you're a bit of a productivity junkie like me and you can never have enough monitors, well, imagine being able to fill the whole room with your work, being able to map out ideas. Think about really being Tony Stark, being able to organize this virtual desktop at no marginal cost as you increase the size of your screen. Very powerful. And we can also make work more fun and interesting and give it the kind of power that you get with step-by-step navigation while you're driving. Imagine if you're doing logistics or you're in a factory, you're doing inspection, you're doing assembly. Any of these tasks where you need to use your hands, you need to be engaging in the physical environment, walking around. But having step-by-step instructions to take you through that. And you can also make it more fun. You can make it entertaining. You can show instructions. So all of this stuff is happening in this little ecosystem that we've begun to build with our developer kit. And we think that it's shaping up to be very interesting. But it can also save your life. Medical error is one of the leading causes of death. Now imagine if through augmented reality, your doctor who needs to have that hands-free freedom to move around, engage with patients, engage with machinery, but with augmented reality has the instructions popping up so he can see it, can actually see patient vitals on the patient, and can go through extensive medical training through detailed simulations to learn how to deal and make the right decisions. And this is in fact happening. This is an example of a team that built a medical simulation training app. They're called SimX, and they showed this at TechCrunch Disrupt over a year ago on the platform. And this has the power to save a lot of lives. And of course, it's important to put things in the physical world, but you can also take the advantage of having the virtual world, being able to bring physical places closer together. Seeing from Total Recall, being able to have where she's real and he's not, the virtual tennis instructor kind of coming in, and being able to bring a 3D model of somebody into the room. So also around video conferencing, lots of interesting things to again bring people together and bring digital things into the physical world. And all this is leading up to a really interesting value chain building up in augmented reality. There is amazing progress being made in sensors around new input types of devices that can track the world. Small microsensors that can track hands like Google Soli. You've got very high resolution displays developing. You've got new active types of sensors that can work outdoors. And all of this is being pulled into augmented reality glasses like the ones that Meta is making and we've been shipping for a year. What we can do now is so much more than we could do when we designed the Meta 1 a year ago. And I'd love to tell you more about what we're doing, but unfortunately I can't. But folks like yourselves, you're integrating all of this, you're taking this platform and building solutions around it. And we've mapped out over 50 different little vertical markets where there are very, very powerful niche types of solutions for augmented reality that rely on a simple set of features that we offer in our platform. And so this is going to lead to really tremendous growth. This market is projected to grow at over 200% compounded annually and to reach $150 billion between AR and VR. And by the way, of that 150, 30 billion is VR, 120 billion is AR. So now Joseph is going to show you how easy it is to build an app in Unity, and then I'm going to tell you why it's really not so easy.
All right, so today I just wanted to show you some of the building blocks of building with the Meta SDK and how easy that can be, and also an example application where you can view 3D objects and visualize them in space in augmented reality. So I'm going to get started by switching over to Unity here, and just here I've got a project where I've imported the Meta SDK. So I'm going to go ahead and open that, and the Meta SDK exists as a Unity package. So a lot of you here, I'm guessing, are Unity developers. If you want to add Meta functionality into your applications or games, all you have to do is import that package. And so here, the first step that I'm going to take is I'm going to remove the main camera and directional light. And I'm going to add a prefab called Meta World. So here I've got a Meta context menu with the SDK, and I'm going to go create Meta World. And so in this prefab, we've got all the cameras, all the gesture functionality, all the tracking functionality that you need to make your application ready for augmented reality. So The first object I'm going to create here is something that a lot of you are probably familiar with, is a 3D cube. And so here I've created a cube. I'm going to move it in front of the camera so that I can see it. I'm going to scale it down to 10 centimeters. So all of these are relative to real scale in meters. So obviously, if you want to be able to grab and manipulate an object, you need to make it small enough to be able to be seen in front of you. And finally, to make this object able to be interacted with by gestures, I'm going to add this script called MetaBody. So in the SDK, we have this script called MetaBody. So I'm going to go ahead and add that component to my object. And as you can see here, there's a few checkboxes to enable the various gesture and tracking functionality on this object. So here we've got touchable, grabbable, pinchable, and a whole range of gestures here. You can lock it to various positions. You can attach it to various surfaces. So if I turned canvas target on, it would lock to a table, or marker target to track it to a marker. And so I'm going to go ahead and make this cube grabbable, and I'm going to be able to move it with one hand here, and I'm going to make it rotate if I use two hands. So I've just checked those boxes there, and I've enabled that functionality. I'm going to go ahead and play this scene. So as you can see, in less than a minute, I've built my first augmented reality app. And here we've got people who've developed in 3D before are familiar with this side-by-side stereo 3D view. And so with the Meta glasses, what I'm seeing in my left eye is the left half of the screen, and in the right eye is the right half of the screen. And that's giving me stereoscopic 3D in the glasses. So I'm going to go ahead and put this on. And so you can see that cube in front of me, and I can go ahead and use my hand and just grab it with my hand and just move it around like that. So it's nice and easy. It's very simple. I'm going to turn the sound up so you can hear that. And there we go. So when I grab the cube, I get a nice little click sound, tell me that I've grabbed it, and I can release it. So what you're seeing there is probably not a real reflection of what AR is. So AR is transparent and see-through. So I can still see everyone around here. I can see all your lovely faces looking at the demo. What I'm going to do is I'm going to go put this in 2D mode so that you can also see and also turn the RGB feed on. So here we go, F2. And so there we go. So this is a more accurate reflection of what you can see through the glasses. So I'm not taken out of the world. I can still see everyone. And I can also see this virtual content in front of me and interact with it. So I'm going to go ahead and grab that again. You can see my hand as I grab the cube and just bring it around with me in the world. It's nice and easy. You also saw that I've enabled the two-handed gesture there. So I'm going to go ahead and use two hands here and just go ahead and grab this cube and rotate it with my two hands. So nice and easy. Less than 2 minutes. So with the Meta SDK, we wanted to enable everyone at any skill level to be able to develop and quickly add augmented reality functionality to their apps. So that's just a quick glimpse of the Meta SDK there. Now I want to show you an app that we've built already that's called Meta Preview. And it is a 3D model viewer. And we've baked in some models there that allows you to interact with those models in 3D space. So I'm going to go ahead and run that. And so, yeah, the Meta system allows you to quickly and easily build your apps and make everything augmented reality compatible. So right now it's loading, it's calibrating the sensors so that it knows where my head is looking and where in the world it's positioned.
And it shouldn't be taking this long.
All right, I might go ahead and try to run that again.
Yeah, so this is always the fun of a live demo. Just worked before this, promise you. Yeah, so what Joe's going to show you is an example of an app that we built to really highlight a lot of the features of the SDK to build more advanced user interfaces. So you can create really full functional user interfaces that are touch-based and click-based using Unity. And then you can embed 3D models that can come out of any system, Maya or any others, along with it. And take it away, Joe.
All right, so here we go. Here we've got the lovely splash screen there. And I'm going to go ahead and put that back in 2D mode again so that, and put the RGB feed back on so that all of you can see what's going on there. And so this is just a quick screen telling me what I can do with this app. So I can move, rotate, scale, and delete. And I'm just going to go ahead and touch the OK buttons here. And then we also have voice functionality. So if I wanted to use my voice to control this app, I could also do that. So what I'm going to do now is I'm going to go and add this lovely telescope we have here. So we've got a few assets included in this application. And so I've got this telescope on the stage. And if I wanted to manipulate it, what I could do is just lift my hand up. And you get to see that little gesture bar at the bottom. Right now it's in grab mode, so I can grab and move it around, just like you saw that cube earlier. I can put that in rotate mode. Whoops. And so let's put in a little macaw here. Oops. And so what I want to do now is put this in rotate mode. Oops. There we go. In rotate mode. So now, once again, you're seeing I've got that one-handed and two-handed rotate functionality. And I can go ahead and put this in scale mode. And what that will do is allow me to make it larger or smaller. And I can do that with one or two hands. So nice sort of intuitive and natural gestures. So imagine the first time, you imagine a child seeing an object for the first time. Intuitively, you want to go and grab it. And that's what the Meta SDK allows you to do, these natural and intuitive gestures. So I'm going to go ahead and delete that object. And I'm going to show off some of the voice functionality of this app. So if I say start voice, larger, smaller, you can see how easy and natural that is. So those are just some of the basic functionalities of the Meta SDK and the Meta Preview app here. And I'm going to give it back to Soren to conclude the presentation.
Yeah, well, let's hear it for Joseph for doing a live demo. Well done. Yeah, so I think you may have gotten an idea also that it's easy, but it's also hard. With all the gesture interactions, mixing the multiple different types of modes. And as I mentioned, our founder and CEO is actually a neuroscientist. And so we've thought a lot about how really this interacts with our whole perceptual system. And so baked into our SDK and our thinking, in our user interface design, and really this should be really of interest to all of you who are interested in the future of human-computer interaction, neuroscience plays a very foundational role. And so, for example, we have to measure things very carefully that are core to the human perceptual system. You can kind of think of this like with VR when you deal with motion sickness and vestibular problems and things. Similar when you're dealing with the human visual system. And I'll talk more about that in a bit. But then you've got how we're integrating not just the visual system, but also your other senses, your sense of proprioception and audio, et cetera. And so that's kind of like another layer in this piece that's needed to create good user experiences. But then you're actually building an app where somebody's got to figure out what they're supposed to do. What's their call to action? What are they doing? And they have to be able to find it without spending too much time searching the environment. And this is not just on a screen. It could be anywhere in this room. So you have to really think about selection, how we decide what we're doing, and how we take action in an augmented reality system. And last, it's fundamentally social. Augmented reality, unlike 2D screens, it's fundamentally collaborative. It's in the space in between us. That's where it's all happening. And that actually influences how we see and perceive things. So I'll just give you some quick examples. You don't really see 3D. You don't see it. All you're seeing are like, retinotopic images on your retina, but there are cues. Your brain then figures out 3D using about 11 different cues. And to do augmented reality right, you have to understand that because you will get better results if you can take advantage of more of those cues. For example, you've got accommodation. That's how your lenses are focusing, coupled with vergence. These are physiological cues. Vergence is the angle of your eyes when you're looking to something to focus on it. And your brain wants these things to line up and be consistent. But it's also taking a weighted average, you can think of it, of a lot of other cues, pictorial cues, the types of things that you as game developers know how to use, motion parallax, occlusion, taking objects of known size, putting them at different distances, blur, et cetera. And so all of these need to kind of fit together harmoniously because they can only fit together one way in the real world. But in the digital world, we can create all sorts of inconsistent mismatches that create bad experiences. And so you actually need to start caring about this stuff. And a simple example of this are these two images here. If you look at the top image, the original image, you don't have anywhere near as clear a sense of depth as if you start using other cues like blur, contrast, and occlusion. And in fact, research and our own usability studies kind of bear this out. If you look at the red, that's the time that it takes somebody to make a decision to do something in a UI. That time is slower than the green line where if you put multiple cues together. So you can see as the complexity of your scene, as your scene gets more complex, you really have to incorporate more cues so that somebody can perform at the same level as in a simpler scene. And so really in terms of being able to scale up augmented reality experiences, you need to integrate these cues. The next level is multisensory integration. You saw Joseph, he's reaching out, he's grabbing things, he's moving them around. How does he know where that is? Well, it turns out that the binocular disparity used in seeing the left and right eye images needs to line up with what his motor system is telling him about depth. And that all has to be done with careful calibration of the optical system, distance between your eyes, et cetera. And that also needs to line up with sound. We're using audio cues, we're using speech. And so we need to have 3D localization of sound. So all of this needs to come together for the multisensory integration to be convincing. And we mentioned that the layer on top of this is around how we find things in a scene, how we make decisions. And this is what, J and D's on the y-axis there, those are just noticeable differences. As your scene gets more complex, you need to use visual cues to draw attention to the calls of action. And you need to have larger differences between things for you to be able to then search a scene and find out what you need to do. And you can see that one of the things that we carefully measure in developing user interfaces for augmented reality is the complexity of the scene and somebody's confidence on achieving what they're trying to achieve in the application and the time it takes them to react. And so as user experience people or HCI people, you need to then really learn how these different cues and things interact to be able to build scenes. But then there's the social aspect. And this is just an interesting bit that, we all have personal space. And objects like augmented reality stuff can scare you if it really gets up in your personal space. And even being in the presence of other people, it affects how you perceive depth in the environment. And this is actually research that shows that our perception of depth is influenced by the presence of other people and the presence of the various types of things in the environment. A bit surprising and unexpected. And I'll just show you a quick demonstration of how some of these cues come together because it's a little hard to grasp. So this sphere looks like it's getting smaller, this cube, it looks like it's getting smaller and larger, and it's in fact moving back and forth in distance. But because it's not matching the depth of field, it looks like it's growing. Whereas if we introduce blur, you can tell very clearly what's happening. And so of course something like this requires actually eye tracking so that you know what somebody's actually focused on in the scene and registering the eye tracking to the environment. So, another example is with lighting. We have real lighting in the environment. So if you have a see-through display, if the digital stuff is working off of different lighting locations in the physical environment, it looks wrong. And so, again, part of tracking the environment, understand where the lighting is so you can get it to match up. And that can lead to something that's then very convincing if done right. And one of the most powerful, one aspect of augmented reality see-through displays is that you can only ever add light. You can't take it away. That's maybe coming in future hardware breakthroughs, but you don't have occlusion in the display of objects. So you need to actually design your models, often using transparency in creative ways so that they look good and convincing. By the way, the jittering and the tracking here is fixed, so don't worry. And lastly, the most important pictorial depth cue that I mentioned is occlusion. And so here, the object, the cube, is moving behind the person, but it looks like it's moving in front of him. And of course, you can't tell that from 3D, but you would be getting really mixed signals if you were looking at this stereoscopically. But when we track the person and use that person to include the cube, you get a much more convincing result. And what your binocular disparity is telling you is the same as what the occlusion map is telling you. So, well, where is this all going? Well, it's been a long time since we put out the Meta 1, and there's so much excitement that we've seen in the space, new people coming into it, and new sorts of things to be looking forward. And while I can't talk exactly about the roadmap, I can kind of give you an idea directionally. And it's about creating that human connection with the technology, something that separates and brings people together. And so wearability is a big part of this. Batteries that can last all day, smaller form factors. In addition, display innovation. It's obviously needed to achieve that, but it's obviously also needed to achieve some of these physiological consistencies in the display technology so that it fits in with our sense of depth and space. Tracking the environment is crucial because it's needed for all these things like occlusion that I mentioned and registering content to the hands for proprioception interactions. And then think about new modes of input, ways that are more cognitive. Like you can think about adding EEGs to be able to pick up electrical impulses in the brain or in the arms or various parts of the nervous system. The creative use of eye tracking and combining that with haptic feedback. And then, of course, where everybody at Unite, the whole Unity community comes in, and that's creating fantastic content. So thanks, and we're going to be here tomorrow as well, so please come by the booth. If you can take, well, Joseph, you know the details on all the workshop stuff, so go ahead.
So on Thursday and Friday, we're running a Meta workshop in Boston. So if you want more details about that, visit our webpage at getameta.com/events. And there's a 15% discount code MetaBooth15. So if you're interested in developing on Meta and building an app in 2 days with us, with the full support of some of our engineers here, feel free to go and sign up for that. We also have a happy hour event on Friday. What time is it, Brittany? 6 to 9. So come down. We've got an open bar there, and you'll be able to see the cool apps that people have developed for Meta in the workshop. So that's open to everyone. So visit our webpage there, and we hope to see you there at our workshop. And also, yeah, thank you so much for coming in, coming to our talk.
Yeah, thank you. So if you have any questions, we'll be hanging out at the booth. And I don't know, do we have time for a question or two now? Do we have any? Sure.
How close are you to portable?
To portable? Reasonably, depends on your definition of portable. It could always be more portable. But yeah, people are doing portable use cases with us now.
I mean, because it looks like you just have us using the MacBook right now. So.
Yeah, that's right. Yeah, so we don't have the compute on the device at this point. But that hasn't stopped people from, carrying around something and really working out these portable use cases.
Howdy. My question is in regards to glasses.
Yeah.
It's something that's kind of a problem with VR as well at the moment.
Yeah, it's a pain.
Very uncomfortable when I'm using my dev kit to actually use my glasses as well. Is that something you guys have thought about for AR as well?
It's something I personally suffered from with our own product, and it's something that I wish I could tell you more about how we've solved it. So.
Okay. Right.
So with the, I'll just quickly add, with the Meta 1, we have 2 switchable lenses. So we've got this shade lens here, which is flat, and allows you to actually wear your glasses underneath. So if you come by our demo booth either today or tomorrow, we can give you a demo and show you how that works.
Yeah, thanks, Joe. More positive than me. Yes.
Would you guys personally consider AR to be less sort of perceptually disorienting than VR, just by virtue of the fact that it does incorporate the real world and doesn't totally construct a virtual one?
Yeah, AR has, you don't tend to have like motion sickness and issues with your peripheral vision, often because you're blocking out less of the physical world. But if you create a fully immersive AR environment, you'll have some of the same problems. So it depends on how you design your content. But yet you can have other problems that you don't experience in VR. So it's different, and you really need that understanding of how to create content that fits in with both the limitations of the technology and with human perceptual system.
Thank you.
You're welcome.
I might add there, so with VR, there's this thing called the vestibular disconnect, where because you can't see your limbs, and you've got this entire virtual world in your glasses, you sort of your body becomes disoriented because there's a disconnect between what your body is actually doing and what you're perceiving with your eyes. So with AR, given you have a fixed reference point in the real world, you have less of that problem because your body knows where it is and it can see this content on top of that as well.
Right. Do you have any suggestions on how to deal with issues where when you move your hand through an object, whereas in real life you'd collide with something, but you don't feel that haptic feedback?
Right. Well, one thing is that you can place content actually on physical surfaces. So the physical surface is giving you haptic feedback.
Mm-hmm.
Of course, that makes the hand tracking a little more challenging.
Right.
But
I know, like, let's say you're moving a chess piece, like you don't feel the piece. So.
Oh, yeah, that's right. And so we don't have a direct solution to that, but you can combine other devices, like we've seen people take haptic feedback from an Apple Watch or a Mayo to give them a little bit of a sense of that. And it's interesting to experiment around with those.
Great, thanks.
Welcome.
All right.
Anything else? Thank you.
Thank you.